All right, so number 3 here. At a local university, GPAs were compared for men and women to see if women have a higher average GPA. Here we go again with the women doing better in college. I'm sorry, guys, it's just the truth. Honestly, I say it to my own boys. I got 2 boys and 3 girls, and 3 of them have gone to college now, and the other 2 are soon to follow. And I always tell my boys, you don't want to be lazy young men, like has happened so much to our culture. Don't be that way. And I'm thankful my boys are doing well. I'm very thankful. But it has been a problem in our society. The stats are showing the men are just not rising up to do what they need to do to get their degrees and get jobs and be responsible. So anyway, I hope it's not discouraging, but encouraging. I try to encourage my own young men to not let the culture influence you. Whoops, what did I hit there? I'm being crazy. I did something crazy. Going on and on about my stories here. Let me get back to it. Lecture 10.2. There we go. All right. Wait, there we go. Question number 3. Sorry, there we go. I jumped away. So I hit a wrong button. Okay, here we go. Let's do it. So local universities, see if men are lower than women GPA. 55 men were surveyed. Average GPA for the men, 2.32, standard 0.72. 50 women, GPA 2.33. That's barely higher, huh? I mean, that's not strong evidence. I'm guessing already. Nah, that's not strong evidence. Standard deviation, 0.65. So probably not strong evidence. All right. So give a 95% confidence interval for the true average difference in GPAs of men minus women. I want to show you one of these that comes out negative. So I'm gonna alter the data. I feel like I'm some kind of a liar, but let's suppose 3.14. So I'm gonna give the women, maybe that's too high. Let's go a 2.95. That's pretty high still. All right. I'm just going to alter the data because I want to show you the other kind of example. I'm not trying to just artificially raise the women, but I just want to show you what happens with the data goes that way. So let's change that a little bit. All right, here we go. So given 95% confidence. So notice this is confidence interval, not hypothesis test, right? Confidence interval, not hypothesis test. So let me come on down and let me grab from the notes. There we go. The information we need. Okay, so here it is. We're talking about 2 independent means. And it says use 2-sample t-test or 2-sample t-interval. So I'm going to do interval this time because we have a confidence interval, right? Confidence interval. We do not have a hypothesis test. So the test, whenever it has the word test in it, it's for a hypothesis test. And whenever it has the word interval in it, it's for a confidence interval. And we're doing a confidence interval this time, a 2-sample t-interval. So that's what we're going to pick. So we're going to do 2-sample t-interval and hit enter. It's stat, on your calculator, and go over to tests and go down. I don't know what number it is. Let's see here. Stat 2-sample t-interval. It's probably way down. Yeah, it's way down on 0. This is like the 10th one down, right? 2-sample t-interval. So confidence interval, not a hypothesis test, right? Says right here, we're doing a confidence interval. So hit that, hit enter. And now, are we going to choose data or stats on this one? This one is stats. Highlight, because we don't have any data. They didn't give us a list of men's scores and men's GPAs and women's GPAs. They just gave us the summary statistics. So we hit stats, we highlight stats and hit enter. And then we put in what we've got. X1 bar, SX1, N1, and X2 bar, SX2, N2. Let's put in the numbers. So X1 bar, the average for the first, who's the first group? The men. 55 men, that's N1. And their average GPA is 2.32. Standard deviation, 0.72. For the women, 50 women were surveyed. That's N2, the women. GPA, I changed it, 2.95, because I'm trying to make the results do something in particular. Standard deviation, 0.65. Okay, put all that in there. I'm doing it right now too. And then the sea level, whatever they said, 95%, 0.95. And pooled is always no. Always no. And then hit enter for calculation. All right, and here's what I'm getting. Now, this is the part I wanted to explain to you guys because this can be a little tricky. Here's the confidence interval I got. I got parenthesis, negative 0.8952, comma, negative 0.3648. Okay, now they want me to round, don't they? Oh, two places right there. Round to two places. So boom, boom. So that'll be negative 0.90. Everybody okay with that? 895, that 5 rounds the 89 up to 90, and negative 0.36. Okay, so there's my confidence interval. Okay, now here's the trick though. Is everybody tracking with me? Everybody seeing this? This is what's going to be confusing for you, is how do you turn this into what they're wanting? What I mean, what are they wanting? They're wanting a number plus or minus a number. See how they're wanting it in kind of a different format here? How do we change from our format where we have the two numbers to their format where they want number plus or minus number? How do we do that? Well, I'm going to need to go to a number line here, and let me show you what we do. This number line is really going from negative 0.90 to negative 0.36. 0 would be like somewhere over here, you know. So we're saying between here and here, right? We are 95% sure that the real average, the answer to the difference is somewhere between 0.90 and negative 0.90 and negative 0.36. All right, well, what they want us to do over here is you have to find the average and the error amount. How do you find the average? How do you find the middle, the average of two numbers? You guys know how to find the average of two test scores, for example, right? You got to take the two numbers, you got to add them, hit equals, and divide by 2 and hit equals or enter, right? That's how we find the average of two numbers. We add them and divide, hit equals and divide by 2. So you got to do that. And you got to use negative, which is the negative with the parentheses on it. Remember the negative button at the bottom of the screen? At the bottom of your keypad, I mean, down by the enter. You got to use that negative. Negative 0.90 plus negative 0.36, hit equals, divide by 2 equals. I'm getting an average of negative 0.63. So that means that's the middle. Negative 0.63 is the middle of that confidence interval. It's the middle. So that's what I put right here, negative 0.63. That's how they want me to answer. They want the middle, and then they want plus or minus, like how far does it go this way and how far does it go that way? That's called the error amount. In other words, we're thinking that the difference, the answer is negative 0.63 right in the middle, but there's give or take an error. It could be a little higher, it could be a little lower. So how do you find the error amount? The error amount equals the middle, the average in the middle, minus the left, right? We can just find the error right here. This error amount right here is going to be the middle number, negative 0.60. You got to put in the negative. Here, let me do that better. Negative 0.63. Want this a little better too, just to be really, oops, really clearly seen. So put in that middle error amount there. Negative 0.63 in the middle, minus the left amount. What's the left amount? Negative 0.90. But you got a bunch of negatives there, right? So, and I'm getting, you hit equals, and I get 0.27. So that means the error, that means this is a jump of 0.27, and this is a jump of 0.27, right? It jumps 0.27 either direction. So 0.27 is the error amount. Does that make sense? I know that's hard for people a lot of times, so I wanted to clearly show that. So we're saying that we are 90, what are we saying? We're saying we're 95% sure, right? This is a 95% confident. We're 95% sure that the answer is going to be somewhere between negative 0.90 and negative 0.36, somewhere on this interval, which has a middle, an average of negative 0.63. How did I find that? I just added those two negative numbers, divided by 2, right? Add them, hit equals, divide by 2 equals. I got the middle. That's how they want me to say it. They want the middle, the average, and then give or take the jump each way from the middle, the error. And how do you find the error amount? The error amount is the middle minus the left. Or you could have taken the right minus the middle. It doesn't matter. I just found this width here by taking the middle minus the left. So I took the middle, the average, minus the left. So negative 0.63, subtract the negative 0.90. And I got 0.27. So that's the error. So we're saying the middle is negative 0.63, give or take 0.27 in either direction. So in other words, we think the difference is negative 0.63, but it's give or take 0.27 error. We know we're not perfect in our estimate, so it's give or take 0.27 error. All right, final step. What's our conclusion? What does that mean? Well, remember what we reasoned earlier about. We're talking about a difference, right? We're taking mu1 minus mu2. We're taking mu1 minus mu2. The women or men? What do we start with? Men, right? Yeah, men. Men came first, then women. Men minus women. So go back here. So it's men minus women. Remember, this is all about mu1 minus mu2. It's two groups. This is where it's confusing for people. They get confused. Remember, we're reasoning mu1 minus mu2. Where does it say that? True average difference in GPA is men minus women, right there. U1 minus U2. You see it? So this answer equals an answer in the interval. What interval? This interval between negative 0.90 and negative 0.36. We are 95% confident, right? We are 95% confident. We're pretty sure. We're not, you never can be 100% sure, because there's always the chance that you got a weird, random, lucky group of men and women. That's always possible, but it's not likely. We are 95% confident that the real difference between all men, this means the true difference for all men and all women at college, right? That's what we're always trying to figure out. What's the truth of everybody? And the way we try to figure out the truth of everybody is we take a sample. We took 50 men and 55 men and 50 women, and the results came in so strong, well, because I changed the numbers. The results came in so strong that we are 95% sure that the real average for all men and women, men minus women, the answer is somewhere in this interval. What does that mean if it's in that interval? Well, if it's in that interval between negative 0.90 and negative 0.36, if it's in that interval, the difference must be negative, right? We're saying it's a negative answer, because if you're somewhere between those two negative numbers, you're a negative number yourself. So we're saying we're 95% sure that it's a negative answer. So what does that mean? How do you subtract two things and get a negative answer? Like 7 minus 10 is negative 3. The first number must be smaller, right? That's what it means when you subtract two things and get a negative answer. So this one is smaller. That's what we're saying. Mu1 is smaller, which is the men. Remember, the second one's the women, right? Men is first. We're saying the men GPA is smaller or less. That's what we're saying. You see? It's less by somewhere between 0.90 and 0.36. We're 95% sure that for all men and women at colleges across the nation, if you compared them, the average distance between them, men would be less by somewhere between 0.90 and 0.36 if you could do the average for all men and women. That's what we're 95% sure of. Let's go back. 95% confidence, the min GPA for men is between lower. Is that right? Between 0.26 and 0.28 lower. Where are they getting the 2.6 and 2.8? Lower. 2.6 and 2.8 lower. Oh, I'm sorry. It's because I changed the numbers, huh? No, sorry. So yeah, I think, where's that? It's because I changed the numbers. I made a difference. So for us, it would say 0.36 and 0.90. Sorry. No wonder that was confusing. 0.36, 0.36, and 0.90. It would say, same thing here, 0.36 and 0.9. It would put the right numbers in there for you. I just changed the numbers on our problem. So we are 95% sure that the average GPA is between that much lower than women. Yeah, exactly. That's what we're saying. We are 95% sure that the average GPA for men is between 0.36 and 0.90 lower than it is for women. That's what that means. And that's also on your exam notes. Everybody know what I mean by that? Let me show you that and we'll be done with this one. So the exam notes, which I gave you right there, I think. Yeah. Oops, what I just did there. Keep doing something weird here. There we go. All right, so the exam notes, there we go. Meaning of the confidence intervals, right? Right here for you. Both negative, all negative, zeros not included, which implies that, oh, it's, and then this thing's wrecking it. It's right where I need to go. This is really bothering me today. This little thing, too much technology for me. I'm overwhelmed a little bit. All right, let's try it again. There we go. I hit the wrong button. There we go. Come on. Okay. All negative, zero not included, which means mu1 is less than mu2. Right. Right? The men is lower than the women. That's what we concluded. That's exactly what we concluded, right? The mu1 is smaller. The min GPA is less because we got an all negative interval. There we go.